Hey math kids, today we're going to talk about inverses, but this time we're going to talk about how they show up on a graph. And so let's just look at Desmos right now. So if I start with this function, it's just a line. What we're going to do to find the inverse is on your paper you'll sketch this line, or you'll be given a graph that looks like that. And then you'll want to sketch the line y equals x. So that's a line that goes up 1, over 1, goes through the origin. And so it's just this, it's a really common function that we use in math. Now what we're going to do is we're going to reflect across this line. And here's the equation, but don't worry about that yet. We'll talk about in a different video how we got that. And see how this black line is reflected across this red line to create the purple line, or the other way around too. The purple line is reflected across the red line to create the black line. So let me just show you real quick how I would do something like this. So we start with 3x plus 1, and so we draw the graph. So we start at 1, and we go 1, 2, 3, over 1. And then just do your best to draw this. I'm not going to grade you too harshly on your drawing, as long as it's within reason. And then if we go up 1, over 1 from the origin, we're going to get that line. So that's our y equals x line that we will draw every single time we do this. And then the yellow one is our original. And then to graph our inverse from that, I like to start it wherever the lines cross. And then I'm going to focus just on this top portion and try to get a slope that's kind of opposite to that. So see how the top part of this yellow reflected to make this blue? And then I look at the other half and I try to do the same thing. Now my drawing is far from perfect, but you can see roughly the idea of what I'm doing. Technically these should look the same on both sides. This slope looks a little bad, but as long as you do something like this, I'll give you full credit. Once again, if we go back to Desmos, we'll see a better interpretation of this, where the original was this purple line, red we reflected across it, and then we made the inverse, which is this black line. Okay? So if anything's linear or any other type of function, you can use this method and it'll work. Now, what I'm going to show you, we're going to have a quick discussion about functions that don't have inverses that are functions, and so we really can't do that. So if I start with a parabola like this, and if I reflect across this line, then I'm going to get something that looks like this. So the problem is, we can see it is a reflection. We reflected this piece and this piece. We reflected this piece to this piece. We reflected this piece to this piece. So we followed the same process, and it kind of worked out. The problem is, a inverse is defined also as a function, and if we do the vertical line test on this purple one, I'll just show you just the purple. See, we're going to fail the vertical line test. So to get around this, what we actually do, instead of graphing the entire parabola, we're only going to graph the positive portion. So now we only have like half a parabola. And when we do this, we can reflect across this line, and then we'll end up getting something that is also a function. So the inverse is also a function. So let me show you this one as well over here. So you're given the function y equals x squared. And so you graph it to see what it looks like. And you're like, okay, I think I need to restrict the domain. And so we're only going to look at it for x is greater than or equal to 0. And so what that means is we're going to erase this part. there. Okay, now we only have that piece of the function. And now we can just go through the same process we did with the line. We draw the line y equals x. The blue is our original. We'll do purple for our other one. So I like to look at where they cross, and then I reflect just that portion. And then I look at this one, and I reflect that portion as well. And so this is the inverse. Okay, if you have additional questions, please come to Math Lab. Until then, calculator.